Okay, this is an easy question. Why? Because they already tell you, hey, identify the Lewis acid and the Lewis base in the following reaction. Okay, so they already tell you, don't think so much, okay? There's a neutralization reaction. There's acid-base reaction, and it's based on Lewis. Okay, so what we're going to do in over here is straight to the point. We ask ourselves, hey, what is a Lewis acid and a Lewis base? A Lewis acid has what? A Lewis acid contribute the empty orbital. A Lewis base contribute the lone pair of electrons. And then that's what happened through dative bonding. That's what we know. And that's what we can, right? Okay, everyone? So my job is to prove this. I need to identify a box, an empty orbital. I need to identify a lone pair. Done. Okay, so first one, all right, OH minus and AlOH3. Someone tell me who is the Lewis acid and who is the Lewis base. All right, OH minus, do you think it's the acid or the base? Confirm base. Why? Because it has, how come we know there's lone pair? Because all negative ion will always have availability of one lone pair, bare minimum. Make sense? There's a minus charge. So this must be the acid. Do you know where is the empty orbital over here? On who? Aluminium. Aluminium hydroxide. You will say, Mr. Chua, isn't it like a ionic? Then remember, this used to be ionic in Sec 3, Sec 4 also. Until when we are where? We are in J1. What the? It was such a struggle, remember? In bonding. Yes. Oh. Then they managed to convince you, no. It's covalent. Okay? Can So consider done. Dative in and then you form this. Right? Bonding is everywhere. I always tell you, chemistry starts with bonding. All right. Okay, done. Keep moving. Second one, obviously, this is quite easy. So I'll just finish up here. All right. The lone pair is here. All right, because it's a negative ion. So this is the base. And this, again, all positive ion will have an empty orbital, because you give electron away, you create some empty orbital, at least one. So this is the acid. Consider that this is the dative bonded product. I.e., in a way, oops, sorry. Where is it? Yeah, sorry. Let me show this now properly. Oops. Yeah, sorry. Oops. Okay, let's move. Okay, next one, number 3. Hey, right? Calcium oxide and carbon dioxide. If I don't tell you it's Lewis acid or base, I ask just like that. Do you think this is neutralization reaction? I can share with you. When you first have the mid-year exam, if this question came out in all schools, I'm very sure it's the 90-10 rule. 90% will get it wrong. Only that 10% get it right. The number could be even smaller. But after a while, people get used to it. So it becomes a 50-50. People still get this wrong. If I ask you, do you think there is an acid-base reaction? Part 3. That's why I say this question easy, because I tell you if there is acid-base, and someone tell you it's Lewis. Understand? So this type of question, you must get the marks. Because no need to think, just apply. Just play. So, play. In case you haven't do this question, ladies and gentlemen, you got 10 seconds to take a look and decide whether it's an acid or base. I would like to hear from you. Calcium oxide. Let's focus on one. Do you think this is an acid or a base? All right, in 10 seconds. So you realize that a question like this will start to differentiate. Plus, I mentioned again, this is considered easy. I already tell you it's Lewis acid base. And I even draw on the right-hand side for you. This will start to differentiate. I was always hoping this could come up a lot for the fun of it. And it's like 5 marks to 6 marks in A level. Damn sure. But people will get it wrong soon. Now, remember, I say acid-base reaction. Follow me closely. Do I just look at this and that? I didn't. I will also look at this. Remember? All 3 theories, I will actually write the full equation. I.e., I will look at the product side. Because the product side will tell you what happened to the reactant side. Make sense? In terms of reaction mechanism in inorganic chemistry. We are going to borrow organic chemistry reaction mechanism to do here. Okay, everyone? Here we go. So what we're going to do. So what do I know? I appreciate that these look like this. Calcium oxide, calcium carbonate. Calcium carbonate and calcium oxide. Ca and CO3. I think it looks like this. It's ionic, isn't it? Same thing. Isn't this ionic also, in a way? So this is where I'm going to do, or what I'm going to do. Calcium oxide become calcium 2 plus and O2 minus. In my head, it looks like this. If you ask me to present, I will present like that. I don't know about you. I already see or saw what I need to focus on. Congratulations to the majority. I think this is a base. O2 minus is a base, means calcium oxide is a base. Why is the carbon dioxide an acid? Remember, a base must have a lone pair, an acid must have an empty orbital. Let's take a look. Carbon dioxide looks like this. What happened over here? How do I create the empty orbital? If I bend this here, which one? This bond. Not bend, but shift it here. Yes? So carbon now have only 3 bonds. Yes? 6 electrons. I 3 orbitals used. He has created an empty orbital. This is a base. Wrong. This is an acid. Dative bonding occurs. We will get used to it. And you see what I see. You want to take a look at the product side? Ready? Yes? CO3 2 minus. Calcium carbonate comes together here. CaCO2. Okay? Inorganic reaction mechanism. Don't neglect this. Remember, reaction mechanism, that always, I mentioned before, that 1 or 2 to 3 marks, or 1 to 2 marks, where maybe up to 3, whereby it's novel. It's not that 5 standard organic chem you learn. So sometimes they'll give you on organic chem the other homologous series reaction mechanism, but they give you clues. Other times they might ask you to do what? They might ask you to do inorganic chemistry reaction mechanism. Okay? With clues or without clues. Usually with clues. Okay, everyone? Okay? They tell you what's happening, right, in statements. Maybe the first step is say, oh, calcium oxide will dissociate, or the ions will split up, something like that, to give you the first clue. Everyone okay? Then you follow the clues. Can? Okay, everyone? Yeah? Alright, then let's move. Number 4, NH3BF4. I think this is quite straight to the point. Once again, we are leveraging on our good concept knowledge of chemical bonding. All right, let me shift this up so they have a lot of space. Here we go. Oops, sorry. Let me just erase off. Yeah. Okay, what is that product dot over there? What is that thing? Ladies and gentlemen, every time you see this, when was the last time you saw this? I will recall. When was the first time you saw it in your life in chemistry? That dot. Who can remember? Who can remember? Remember this thingy? The only blue salt you know in your life. It was all there, but we couldn't teach you in Sec 3 and Sec 4 because you don't know what is happening. You want to see what is happening? I can show you. This is our last topic called transition metals. When we reach there, then I can show you because it's not easy. Okay? There's some school that went in. I don't know why your school went in. They must be very smart, their student. All right? Copper 2 plus, SO4 2 minus. Where was this dative bonding? It means there is 5 water molar Q. Yes? Can I don't draw 5? There are lone pair of electron, and what happened? Copper 2 plus has a lot of empty orbitals. This is how your hydrated salt is formed. Okay? Don't need to go too much. All I want to say is whenever you see a dot, all you need to know is A, there is dative bonding. Which means I'm very sure there's a Lewis acid-base reaction that created this thingy. So copper sulfate, you ask me, is this product created based on Lewis acid and base? Is this a dative bonded product? Correct. What's called dative bonded product? The dative bonding is like that one. There is dative bonding. Okay. Yeah. Water got no lone pair. Copper 2 plus is a positive ion. But how come there's so many empty bottles, empty orbitals? Akan datang, right? To be discussed in traditional method. Okay, ready? All right, so very easy. Once again, acids and base. We know this as a lone pair. This must be a base. BF3 on the B, there is an empty orbital, so it's an acid. BF3, once again, is a molecule. There is what? In bonding, covalent bonding. We say the exception to octet rule. Remember? They are electron deficient, but they are stable. Those I've taught you bonding before, I was very clear. I say you better memorize this. I seldom ask you memorize things. When I say memorize, you memorize. Alright, so go back and revise your bonding. Very important.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.